Ladies and gentlemen, I recently came across a pretty interesting question. Where do we find the most exclusive air in the world? High on top on the mountains or at any remote island? Actually, the most exclusive air in the world is being found in deep underground mines, because fresh air is being pumped down through ventilation shafts to generate a constant flow of airstream to the underground workings. And this has to be done to dilute and to remove dust and noxious gases and to regulate the temperature deep down in the mines. Mine ventilation systems normally operate 24 hours a day, 365 days a year, and they account for about 25 to 40% of the total energy cost of a deep mine operation, which is, for an average mine in absolute figures, about 20 to 30 million US dollars running costs just for mine ventilation per year. In addition to this, significant capital expenditures have to be built have to raise to build ventilation shafts and to install the corresponding ventilation equipment. So what are the challenges that the mining industry globally is facing in the forthcoming years? Due to lower mineral grades and mineable ore bodies, which can be found only in greater depths of the earth crust, mining is becoming more and more challenging. Much more bulk material has to be blasted, extracted, and transported to produce the same amount of mineral concentrate and even to increase the mining production at all. What is more, mining companies have to consider tighter environmental, work safety, and health legislations. And this refers in particular to limits regarding exhaust emissions of diesel engines, as well as maximum values for noise and vibration loads for the mining equipment operators and for the mining personnel at all. So therefore, to increase the number of diesel trucks or to increase the trucks with higher payload capacity and necessarily bigger diesel engine, that cannot be the answer to those challenges. A new approach is needed. And when we as Siemens speak about a new approach, then we mean the stepwise implementation of electrical drive systems for underground vehicles. Based on our proven drive systems for electrical vehicles, for instance, for buses, trams, trains, we have adapted standard components and used them as a new drive system for existing underground mining trucks. This is part of our business strategy to improve the working conditions in deep mines, to increase production and productivity, and this way to enable mining in ever greater depths. This slide represents the architecture of our new electrical drive system for mining trucks. In our particular application, we use 4 electrical wheel motors, each one driving one wheel. They get provided with alternate current by a double alternator, and this particular application enables us to control precisely speed and torque for each wheel individually. In addition, we can also equip our drive system with additional features such as advanced slip-slide control or electrically supported steering. What is more, when it comes that we can precisely control each turn of the vehicle, then this leads to a reduction of tire wear, which saves cost. And we can also complement our system with energy storage components, which also can be done afterwards on requirements of our customers, and of course, depending on the availability in the market. A few words about the timeline of our current prototype project. We have, in the meantime, designed and produced all the hardware and software components of our drive system for a 60-ton mining truck. And it's now, these days, being shipped to our first customer, an Australian gold mine. We expect that the drive system will be installed, implemented during the summer, and after that, an extensive field test has been scheduled. Depending on the results of this testing period, we are then right on the jump to produce this new drive system in series. So what are the benefits of a diesel-electric drive system compared to a pure diesel mechanical system? With diesel-electric systems, your truck is running faster because the overall efficiency of the system is much higher. More diesel power can be used for propelling the vehicle uphill, and another advantage is higher productivity due to shorter cycle times. Shorter cycle times means it is possible to transport more material in a certain time window compared to a vehicle which is slower. What is more, we also expect less maintenance expenditures for our customers and a higher availability of the trucks for the mining operation at all. Based on our experiences with big mining trucks in open pit surface mines, we expect a reduction of maintenance expenditures by around 15%. And we also will see more favorable environmental conditions for the mining operators and the personnel due to less heat and exhaust emissions, which brings us back to our initial question, what can we do to reduce the efforts and expenditures for mine ventilation? Finally, a few words about that, what we will see and can expect in the forthcoming years. There are about 1,000 deep underground mines, significant mines, today worldwide in operation. In these 1,000 mines, there is an installed base of about 30,000 vehicles, such as wheel loaders, mining trucks, drilling machines, etc. And with progressive development of electromobility, we see a huge market potential for our new drive systems, and we see a huge potential for integrated solutions towards an all-electric mine at all. In any case, we as Siemens, we are well positioned and prepared for this exciting development, and we hereby also invite you to discuss with us possible fields of application, of cooperation in your special field of application. Thank you very much for your attention.
Okay, thank you. So if there are questions, then we can answer those questions immediately. I would have at least one question, and that was about the, if you would go to the micro. In agriculture business, we are doing the same thing. We are putting wheel hub motors and other electrical machines into the, and we really suffer of the weight and the cost of those machines. And one very important and reasonable way will be in the future to speed up those electrical engines in order to increase power density up to the 10,000–15,000 RPM for an electrical machine. Which engine speed do you have in your electrical machines?
Our engines, 1,500 respectively 2,000 RPMs.
So it's huge engines. And these are off the shelf or specifically designed for the application?
These are machines which we have standard components which we already use in different vehicles, and especially for these mining conditions, we adapt them. For instance, when you take a motor which is, for instance, has is aluminium produced, we need in mining some more stronger machines. So we will put it in an iron, or we will produce it based on iron, and we will make it more robust regarding dust, temperature, and everything. So actually, our strategy is to have a portfolio with a number of components, motors that can be converters, electronics, alternators, etc., and then to adjust them to the specific conditions in the industry, and also to write a software to that and to apply to the certain conditions. Because from cost point of view, you can imagine we have efforts to develop these systems, these components. It takes some time, so it's better to have a portfolio available to take that and to adjust it to the specific industry requirements.
Okay. Is that an internal development, or do you also using electrical machines from other suppliers?
Actually, of course, we always will try to find all these components, electrical machine, etc., within our portfolio. But sometimes we have to recognize that we either don't have that in our portfolio, or the customer wants to have other solutions, or sometimes there are some other components cheaper available on the market. For instance, when you take axles or gearboxes, Siemens has also, we have bought Flender a few years ago. We can offer gearboxes, but when the customer says we want to have gearbox from an external supplier, so then we are absolutely open for that discussion. That is a question of negotiation, but in the end, when the customer wants something, then he gets it.
Okay, thank you for that answer. Is there any other questions?
Power rating is the engine, and how you propose to replace that with electric drive in the future?
You mean the power rating in terms of kilowatt per hour? Actually, for this particular application, what I showed you here, it's a machine with 120 kilowatt per hours. Actually, we have experiences with those big mining trucks, machines with 1 megawatt, etc. So it's actually a pretty new market for us, these underground equipment. We have an installed base worldwide with Komatsu, Hitachi, Bellas, Chinese companies, Liebherr, Caterpillar, with more than 800 trucks, which are in the range, with 1 megawatt, and even where we are also very proud on that we have equipped the biggest truck in the world, the 500-ton truck from Bellas, with our drive system. So actually we were in the past more in that field, 200, 300, 400 tons payload for these trucks. But nowadays, because of the progressive development, electromobility, and we see the demand from the underground mines coming, so that's why we feel enforced also to cover this market, which was in the past not our focus, and we start now to also to cover and to offer components for machines in that range.